going to speak about quantum computing software and a short intro before. So Classiq is a quantum computing software company, actually the largest quantum software startup today. We are a team of 65. Most of us are located in Israel, in Tel Aviv, but also we have offices in Amsterdam, New York, Tokyo, and hopefully Paris soon as well. And this company was established 3 years ago for one simple reason. This is the reason. Quantum software development is a challenge, a great challenge. You know, quantum hardware is being developed and it's getting better every year. But quantum software development is still limited to the gate level. Well, if you want to design some toy circuit, that's great, go for it. 3 qubits, 4 qubits, 5 qubits if you are good. When you try to scale to a few hundred qubits, few dozen qubits, it's already getting very challenging, but scaling to real-world applications, this is not the way. So when solving this problem, we started by looking at the history to similar design challenges that were already solved. Let me give 2 examples. One of them would be engineering. Like 60 years ago, when engineers needed to design a bridge, for example, they needed to take care of every tiny detail, which took a lot of time, months, even years, and a lot of expertise. And today, this is not the case, because today, using Autodesk, for example, engineers can model the building, for example, but the little details are automated, right? Which makes the design much more efficient and more complex. Another example, much more relevant to our field, would be chip design. 60 years ago, when the number of transistors on a chip raised to a few hundred, with a few hundred gates applied on them, gate-level design became impractical. And this was the early days of electronic design automation, right? Today, chip designers can model with VHDL very complex chip with billions of transistors because the gate-level design is automated. And this is what Classiq brought to quantum software. Classiq automates the design of quantum circuits. And by bringing these design automation methodologies to quantum software, we have built the operating system, the compiler, and the IDE for large-scale quantum software development. Now, let us have a look at the process like it's being done today with Qiskit, for example, which is a fantastic platform, of course. So when you develop at the gate level today, what you need to do is to design a circuit. It is your responsibility to build the gate level circuit. So you will choose the functionality, you will use some building blocks, some quantum gates, you will modify it, you will optimize, and the last mile will be automated, right? Compilation is automatic, of course, but this is only the last mile. With Classiq, the process looks different. With Classiq, you define the functionality. You focus on the functional model, what's your intent, what you want to achieve, and also on the hardware constraints, right? It could be anything. It could be qubit count, and when the noise model and connectivity and so on, and then you let automation go through the entire design space, millions of different circuits, and it will stop when it finds the circuit that both meet your functional demands, and it is also optimized for the constraints you apply on or for a specific machine. And of course, after that, you are free to run it on all available quantum clouds, quantum computers, quantum simulators. We are integrated with all of them. It's already too many slides, so let us see how it looks like. What we are going to see right now is how to model a circuit in almost no time. It will be automatically generated, and we'll execute it, in this case, on the IonQ machine. So let's choose evaluate risk model for finance. You will see here no implementation, no gates, only functionality, and we can then apply some constraints. We want it to work on maximum 15 qubits, maximal circuit depth is 1,000. We want it to work on the IonQ machine, and we synthesize. Now in 2 or 3 seconds, a quantum circuit will automatically be generated. And of course, now we should start exploring it. We want to open it. We first give it a name. And then we open it. We see that it is built of many functions that were created automatically. We can explore them, and we open and open and open until eventually, of course, we get a gate-level circuit, right? And after we get this gate-level circuit and we are happy with it, we can execute it. Again, on every quantum computer that is available via the cloud. In this case, we'll use Azure Quantum and the IonQ simulator only for the sake of time. And we choose the number of shots we want to apply. 1,000 will be good enough. And we run it. Now it's being sent via Azure Quantum to the IonQ machines. And we very quickly get the results. Now, it was a simple model, a simple circuit, only 9 qubits. And of course, we can design automatically much, much more complex algorithms, more complex circuits. Let's have a look at a Grover search, for example, that was automatically designed. You see many embedded classical functions within the quantum circuit, or a QAOA circuit for a real-world optimization problem with a few hundred qubits. Now try to design this with Qiskit. That would take some time. So this is the idea. The idea is really to model, to embed constraints, and let automation do the rest. Now, of course, there are many different applications, and you can access it via Python, via the SDK, and so on. Let's move forward. OK, so this is what you have just seen, an end-to-end quantum software development solution from modeling, circuit synthesis, visualization, debug, and execution. Now, many organizations are preparing for the quantum era, want to be quantum ready. But what is really to be quantum ready? Is a POC, is it equal to be quantum ready? Probably not. So when we work with partners, it's really important for us to start with a more general quantum software education methodology. Many algorithmic schemes, many implementations, benchmarking, not to focus from day one on one specific use case. After that, of course, we explore many different applications. All of these are embedded in the platform, and we are free to build more and more and more. And then, of course, we want to implement. We will do some proof of concept from modeling a use case, industrial use case, benchmarking different machines, and essentially building the models that will be ready for tomorrow when the large-scale machines are really here. And after that, we can indeed focus on one specific use case and create some quantum assets, IP, and so on. The nice thing about this ecosystem today, I think, is we are all building it. It doesn't matter if you are a hardware provider, software provider, service provider, enterprise, investor, analyst. We are all building this ecosystem together. And in Classiq, we are really, really privileged to be working with some of the leading organizations that are taking this field forward. And I wanted to share a few examples from the recent couple of months. So the first one would be a really beautiful work done by the Rolls-Royce team in modeling the CFD problem using the HHL algorithm into the Classiq platform. Then the circuit, which is quite complex, was generated. And this is really a beautiful forward-thinking research, and we really appreciate that. We recently partnered with KPMG for joining KPMG's quantum expertise with the Classiq platform and expertise, of course, to bring the most advanced quantum stack for enterprises. With our friends at HPE, we are building together the quantum stack for HPC users. It is built on top of the Cray stack, and we embed the Classiq platform as the entry point for hybrid classical quantum development. Of course, when we think of the next generation of quantum software engineers, it's very important to work with academia. And our platform is is really suitable for that, right? Both for research and education. So last year, we initiated our work with academic institutions. This is a quantum computing course in Carnegie Mellon, for example, given by the Classiq platform. And recently, we partnered with Microsoft, and we have launched together a global academic program for bringing the joint product, the Classiq platform, on top of Azure Quantum, free for research and education. It was launched a month ago when we already have users from over 100 universities globally, and you are very welcome to use it as well, of course, if you are from the academia. And with this optimistic view of the next generation of quantum software engineers, I would like to thank you, and I promise to be quick. Yeah, it was okay, and I'm very happy to answer any questions now or later on.
Thank you, thank you. Yeah, I think we have time for a few questions if you want. Raise your hand and the mic will arrive. There's a question over there.
Oh, thank you. Is any standard developer may be able to have its quantum algorithm and calculation without having a quantum expertise? That's what your software is offering, meaning some hours or some days of training to be able to use your software. Is that correct?
Yeah, definitely. I think it's very much about enabling both quantum experts, but very much also non-quantum experts, domain experts, to bring their knowledge into the quantum space, to model their domain-specific problem in a very abstract way to a quantum circuit without doing the gate-level development. So definitely, this is very possible.
Yes. So do you believe it may be possible to have, in few years or in few months, like libraries usable for by anyone? Like
why few years? Already now, definitely. There are many pre-built functions and pre-built models in various use cases. So of course, any user is free to use pre-existing pre-built building blocks and models, but also to build new ones. So definitely, I think on the one hand, many libraries should be open to the public for research and education, but also if an enterprise, for example, wants to build their own IP, they could do that. No one should know it's their IP.